Okay, here we are on this video of function notation. So a function consists of variables in both the numerator and the denominator. Then it's going to have these properties, and we're going to apply these in a moment. So let's consider this function, okay? F of x, some function of x, is equal to x take 2 divided by x plus 3. It's going to have zeros. It's going to equal 0. It's going to cross the x-axis. It's going to have its roots when the top equals 0. Okay, so that is x take 2 equals 0, and the solution to that is x equals 2. When x equals 2, the function is 0. That's its x-intercept. That's what we call its roots. Okay, let's look at the second one. It's going to be undefined when the denominator is 0. So that's going to be when x plus 3 equals 0. The solution to that is x equals minus 3. All right, it's going to be undefined at that point. We're going to have a vertical asymptote at that point. Because if you put minus 3 into this equation, all right, minus 3 plus 3, you have 0 at the bottom, and we can't divide by 0, right? So they're the two properties that we're exhibiting, and we're going to have an application of it in this example. Firstly, function notation, okay? We've got f of x is this function here. It's the function with regards to x. And we're asked first, find f of 0. That means we put the number 0 everywhere there's an x. So f of 0 is going to be 0 squared plus 3 times 0 plus 2. All right, that's what's going to be at the top. And at the bottom, we're going to have 0 take 2. That's f of 0. And we're going to evaluate it and simplify it so that it comes out in simplest terms. So 0 squared is 0, 3 times 0 is 0. So at the top, we're just left with 2. And at the bottom, we have 0 take 2, which is minus 2. 2 divided by minus 2 simplifies to minus 1. So f of 0 is minus 1. All right, what this means, when x is 0, the y value, the function is minus 1. All right, so that's part A. Let's move on to part B. It says find f of 1. So f of 1 means we're going to put the number 1 everywhere there's an x. So we're looking along, we're going to have 1 squared plus 3 times 1 plus 2 divided by 1 take 2. Okay, and so this we're just going to have to simplify slowly. We've got at the top 1 plus 3 plus 2, and at the bottom we've got 1 take away 2. Now 1 take away 2 is going to be minus 1. So 4, 5, 6, 6 divided by minus 1 will be minus 6. So here's the function of x. We put positive 1 in. When x is 1, the function is minus 6. So the y value when x is 1 is minus 6. Okay, let's move on to C. We have f of minus 1. I'll do this one a bit faster. All right, I'm going to put minus 1 everywhere there's an x. Now notice how it's x squared. So that means it absolutely has to be in brackets. It's the x value squared. Okay, and that's important because that's going to turn out positive. Divided by minus 1 take 2. Okay, minus 1 squared is minus 1 times minus 1. So positive 1. Take 3 plus 2 divided by minus 3. And let's evaluate this. 1 take 3 is minus 2. Minus 2 plus 2 is going to be 0. So we have 0 at the top and minus 3 at the bottom. Now 0 divided by minus 3 is 0. We can divide 0, but we can't divide by 0. Okay, so you can remember that. We can divide 0, we can't divide by 0. I like to think of it as cakes. If you have 0 cakes divided by 3 people, everyone gets none. All right, everyone gets 0. But if you have, 5 cakes divided by 0 people, it doesn't make sense. You can't divide 5 cakes amongst 0 people. There's a fault in the problem. So that's a good way to think about it. So that's legit. When x is minus 1, the y value is 0. Okay, let's move on. For what values of x is f of x undefined? Well, let's jump up to our dot points here. The function is undefined when the denominator is 0. Okay, here's our function. Here's our denominator, x take 2. So to answer part D, it's going to be undefined when x take 2 equals 0. When the denominator equals 0, how do we solve this? We're going to add 2 to both sides. The solution is x equals 2. When x equals 2, this function is going to be undefined. It doesn't exist. There's a vertical asymptote at x is 2. All right, and then we'll move on to E. For what values of x is the function 0? Okay, for what values of x is the function 0? Well, the function is 0 when the numerator is 0. So the numerator of our equation then is x squared plus 3x plus 2. And we're saying, when is that equal to 0? Now this here is going to be a recap of what we did right at the end of last year with our orientation. All right, we're solving this quadratic equation. And it's not going to be in this test explicitly, but it will be in the next test. So I'm going to brush over this skill now, but don't be alarmed if you're like, how do I do that? I've sort of forgotten that. There will be an opportunity to develop this skill in our next unit. Nonetheless, let's go ahead and solve it. We have a quadratic equal to 0. We're looking for two numbers, so we're going to use the cross method. Two numbers that multiply together to give us positive 2, and when we add them together, we get 3. Now, the multiples of 2 has to be 1 and 2. All right, and what you can see is x times 1 is x times 2 is 2x, and when you add them together, you get 3x. That means this is our solution. All right, so this quadratic can be expressed like this: x plus 1 times x plus 2. All right, we can move from there to here by the process of factorization. Another way to check you're correct would be to expand that, to use FOIL and expand it, and you would obtain what we've got up here. Okay, so that's a bit tricky. Let's assume for now that we're okay with that. Not a skill that's going to be in this test coming up. So we've moved from there to here. We've just changed the way it's expressed. It's equal to 0, and now we're going to apply the null factor law. That is, if we have a times b equals 0, then either a is 0 or b is 0. All right, we're going to go through and solve. The solutions are -1 or -2. For those two values of x, the numerator will be 0, which means the function is 0. Those are when the x-intercepts and the roots occur. So this exercise starts off reasonably okay. Like, it just starts off, put some numbers in and so forth, make some comments about when the numerator is undefined, when the denominator's when the denominator is 0, when the numerator is 0. So using those properties. So that's going to be 3b function notation. All right, hope you go well with it. Just, get as much done as you can, and I'll make sure I answer some of the questions that you guys have in class.